Hey everybody, and welcome back to the for loop. And this is our fourth and I believe it will be our last tutorial for this series of just basic object-oriented programming. And I really want to cover some of the deep definitions of object-oriented programming and what you'll really need to understand if you really want to conquer just the ideology and the way that object-oriented programming works, and also, to be honest, if you ever want to try and get a job or career in the OOP language, you'll really need to know these words and definitions and how they work together. So I'm just going to start off with the first one. We've got four that I want to get through, and this shouldn't take too long. So we've got polymorphism. Okay, so don't let it shock you. Polymorphism, the first time I heard it, I was like, what kind of Greek word is this? Why do I need to know this, right? But anyways, as you can see, poly, most of the times when you hear of it, poly just is going to mean many shapes. Or actually, poly will just mean many, and then of course, I've already given it away. But you can think of like the transformers, morph means shape. So you can think of polymorphism as just many shapes. And I'm going to take this kind of slow because I don't want to screw it up, and I want to make sure that I describe this correctly because these are really important things to know. So, and I just want to say that polymorphism is a way to use a class and reuse it over and over. Here, just let me write it out, and I think it'll make more sense. So, in the last tutorial, we had a class called basketball. Well, let's imagine that we had a class called ball, and the ball class had certain methods like method 1, for example, and method 2, for example. I know it's pretty original. Oh well. And then let's say we have another class called basketball, and there's this cool little thing you can do called inheriting. So we can say inherits ball. Oops. So we can say inherits ball, and now we already immediately have all the properties and methods that ball has. And what makes this so cool is now we can go down here and call class, we can make a new one called baseball inherits ball. And now when the computer looks at this class and sees that you said inherits ball, it'll be like, oh, this is cool. So baseball already has method 1 and method 2. Awesome. So this is part of the importance of polymorphism. There's other importance as well, and I'm just going to write these out. So we have override and overload. Override means we can take method 1, take it down here, and say override method 1. And then we can write a new little function in here. Oops. And whenever you're talking about a basketball in your main method, the computer, and you call method 1, the computer is going to look at both of these methods. It's going to say, okay, ball has method 1, and also basketball has method 1. But since we're talking about a basketball, I'm going to choose method 1 out of the basketball class. And I hope that makes a lot of sense. Let's say let's change this to bounce, actually, and I think it'll make more sense. So you can see up here, if you have a ball and you bounce it, well, you're gonna ask me a couple questions. You're gonna say, is it a basketball? Is it a football? Is it a baseball? Is it a rubber ball? What kind of ball is it? Is it a beach ball? But when you go down here and you call it inside of basketball, you know it's a basketball, so you kind of know what the bounce will be like. Whereas down here in baseball, you could call the same method bounce, and you would have to override it. Override. And you would know that a baseball really doesn't bounce. So you can kind of see what I mean. Like, all balls have bounce, but certain balls have bounce different. So you need to overwrite those methods, and so the computer understands that they're different from one another. Whereas, like, let's say you have shape up here. You know that a basketball and a baseball, they both have a round shape. So you don't necessarily need to overwrite that method. And I understand football has a different shape and other balls probably have a different shape. But anyways, you get the idea. Okay, let's go on to overload. So overload is actually, let's say you have bounce with no parameters, and then you have another one, bounce, I'm just going to put it up here. So you have a bounce with no parameters, and let's say you have a bounce with like a couple parameters, string, str. So there you can see it. You have two bounce methods. Now when you call bounce in your main method, the computer's going to say, okay, well, what bounce are you talking about? And the way that the computer tells is how many parameters you put in it. So you can see I put no parameters in this bounce, so obviously the computer knows it calls this guy. But let's say I didn't actually do this correctly. Let's make more sense here. So new basketball. So you can see it calls this method. It's actually going to call this guy right here because I overrode the bounce with no parameters. But then if I'm going to go down here and call bounce with two parameters, int I and string str, then it's going to look in here and it's going to say, well, you don't have that method because you don't have a method with that many parameters. But your parent does. And that's also something that this class, upper class, is considered a parent class, and this underclass is considered a child class. And as you can see, ball can have multiple children classes, baseball, football, basketball, but basketball can only have one parent class. And you can even go and have another class above, or you can have let me think of a good one here. You can have another class that inherits basketball. So if I had a class C, make up your creative mind so that you can come up with this because I can't. Let's say class C inherits basketball. Then you can see that it not only inherits all of basketball's methods, but it'll also inherit ball's methods. So ball has multiple children and grandchildren, and then class C, of course, has one parent. Basketball has one parent. So there you go. So parent, child, classes. That's polymorphism in a nutshell. So I advise you to look up the definition on polymorphism, and this is just sort of like a simple version and try to explain it out so you can understand it. All right, let's go on to the next one. Inheritance, I kind of already covered this. It essentially is also very, very close to polymorphism. So you have parent-child classes, and I might actually just move this down here because inheritance and polymorphism really go together. So we already talked about inheritance, how the child class can inherit methods from the parent class. Polymorphism means that you can take the parent class and you can be more specific with your child classes and making it either a basketball or a baseball, and you can see how you can turn a ball into many different shapes and sizes. Then you have your inheritance class, which means a child class can inherit from a parent class. Next thing I want to talk about is encapsulation. Let's type. Encapsulation. Okay. The idea of encapsulation, and I brought this up in the last tutorial a little bit, is the way I think of it is a calculator. And when you hold a calculator in your hand, like one of the ones we used to use in math class in high school or junior high or whatever, grade school, wherever you used a handheld calculator, you think about it as the calculator does all the smart thinking, all the smart data, but it doesn't show you all that data. So that's also the idea of encapsulation, is hiding unimportant data. That way the user doesn't have to deal with all that junk. It doesn't have to think about it. It just gives you what it wants, says get me the color, and you do all the calculations and return the color. So I feel like encapsulation is pretty simple. It's just wrapping everything inside of a class, which is what object-oriented programming is. So we're wrapping it inside of a class or an object, and then we're doing all the smart thinking and everything inside of the class, and we're hiding it from the user so that he doesn't have to deal with all that garbage. So one last thing I want to talk about, abstraction. And this abstraction is defining your object by distinct details. And I hope this description makes sense to you guys. But if I can dive into it a little bit here, defining your object by distinct details means when you define your class or your object, one of the things you have to do in your properties is decide what properties are important and what properties are going to set this object apart so that I can refer to it in my code and the computer knows what I'm talking about. And you can see what I'm saying when we talked about class basketball versus class baseball. They're obviously different things. You can think of size, you can think of shape, you can think of color even, you can think of how much they bounce when you throw them on the floor, you can think of what kind of players use the balls, and you can see how you would need to describe properties in order to make them distinct. And also, we went over this when we were talking about our basketball class. We saw how when I wanted to make a new method called pass the ball, or pass, I think is what we called it, I had to go back and describe two new properties, x position and y position, and that's also part of your abstraction. You're defining distinct, or you're defining properties that make your object distinct, and also make your object so that you can use it according to your methods and how you want to describe it in your constructor. So these are the four things you should really know: abstraction, encapsulation, inheritance, and polymorphism. And I know they're big words, but essentially if you know the definitions, you'll be way ahead of where you were yesterday, to be honest. If you want to, like, if you're going into an interview or anything for object-oriented programming, I guarantee you'll hear 2 out of these 4, if not all 4, and you'll be asked to not only discuss or use them in your conversation, but they'll probably put these words inside of the questions that they ask. Not necessarily asking you to define inheritance or define polymorphism, but maybe they'll say, like, how would you use polymorphism to blah 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 define aircraft carrier versus I don't know, aircraft carrier versus a pirate ship, I don't know, for a boat. Anyways, it's really important for you guys to know these 4 things, so I really encourage you to look these up for yourself. Try and understand try and understand the descriptions in your own way. These 4 descriptions are the way that I understand them, and so I know everybody has their own way of learning. So that's all I have for today. Thanks for tuning in, and that ends this series. So please subscribe to the For Loop, and I'll have some more great tutorials coming in the future. See ya.